Question number 5. The figure number 10 shows a child's toy. A child pushes down on the toy to compress the spring. The spring then launches the toy into the air. You can see here in figure number 10, the spring is present in the toy. When the spring is compressed, it means that the spring has elastic potential energy. When we release the toy will move into the air. So elastic potential energy changes into gravitational potential energy. Let's see 5.1. 5.1 is an AO3 and AO1 combination question, and this question is from the topic of change in energy. A student measured the maximum height reached by the toy. The student placed a vertical meter ruler near the toy and observed the height reached by the toy. The student repeated the experiment, observing from the different position. The figure number 11 shows the toy at its maximum height and two positions of the student. If you look here in position number A, the toy is above the eye level, whereas in position number B, the maximum height is at the level of eye. So the student in the position number B is in a position where he can find the height of the toy more easily and accurately. Observing the toy from position number B instead of position number A affected the measurement of the maximum height reached by the toy. Let's see the model answer. The measurement is more accurate in position number B than in position number A, and the reason is the toy is in the level of eye, whereas in position number A the toy is above the level of eye. Because the maximum height of the toy is in the level of the eye of the person in position B, whereas the extra information is given that in position A the toy is above the eye level of the person. The marks distribution is given here on the left side of the answer. .2 is an AO2 question. The student need to apply the knowledge. And this question is again from the change in energy. The greatest height reached by the toy was 64 centimeter. The value is given in centimeters. We need to convert the units from centimeter into meters, and we know that 1 meter is equal to 100 centimeter. The gravitational potential energy of the toy at the height was 0.049 joules. So energy is given. The value of G is also given, that is 9.8 Newton per kilogram. Calculate the mass of the toy. So in this question we are given the height, which is 64 centimeter, and we need to convert centimeters into meters. We need to divide 64 by 100 to convert centimeter into meters, because 1 meter is equal to 100 centimeters. So the answer is 0.64 meters. The gravitational potential energy value is given, that is 0.049 joules, where the value of G is given here, 9.8 Newton per kilogram, and we need to find the mass of the toy. So we are given gravitational potential energy, so we need to use the formula for gravitational potential energy. Let's see the model answer. We know that gravitational potential energy is equal to mgh, mass of the object, times the gravitational field strength times the height covered in the air. So we will substitute all the values, which is energy, we're going to put it here. Mass we need to find. Value of G is 9.8, we need to put it here. And the distance covered or the height covered in the air, that is 0.64. After substituting the values, we need to find the value of m. So these two values will go on the other side of the equation and divide 0.049. By using the calculator, the answer is 0.0078125 kilograms. But the demand of the question is up to two significant figures. Therefore, first two non-zero numbers are 7 and 8. Students sometimes make a mistake. They consider the first two numbers 0, 0 as two significant figures. For the first two significant figures, we have the answer mass is equal to 0.0078. The correct answer is mass of the toy up to two significant figures is 0.0078 kilograms. 5.3 is an AO1 question, and this question is from the topic of energy stores, energy transfer in a system. When the spring launches the toy into the air, the temperature of the air increases. Explain why the child's toy on its own is not a closed system. The student must know the definition of the closed system. Closed system is a system in which the energy is not wasted. Therefore, the energy of the system remains conserved. But if you look into the statement of the question, when the toy is released in the air, the temperature of the surrounding air is increasing. It means the energy is converted into the energy of the surrounding air. Let's see the model answer. When the toy is released, the energy is transferred to the surrounding air, mean the internal energy of the air, whereas the total energy always remains constant in a closed system, means energy is not wasted. The marks distribution is given on the right side of the question.